what am I going to have to add if I've got a composite function? What have I not taken the derivative of here? Yeah, u, which in this case is going to be the exponent. So now I have to take the derivative with respect to x of that exponent, 4x squared, da-da-da-da, okay? So down here I'm going to have to take the derivative of u with respect to what? Down here. And the answer's over here. Same input, right? With respect to x. Now, the reason I said that you only have one, you don't have three exponentials to think about, is because if you apply this to this one, what does it look like? So let's try that. I'm going to apply this rule right here to this problem. So I have the derivative with respect to x of e to the x. First thing we do is say e to the x times the natural log of the base. What's the base? E. Times the derivative with respect to x of the exponent, which happens to be x. Now, what is the natural log of e? E to what power? Now let's do it this way. There we go. Do it this way. We have, okay, natural log of e has a value, which means that this exponent is on the base and it has the same value as e. So what power of e gives you e? Just 1? Okay, so we have e to the x times 1. What's the derivative of x with respect to itself? 1. So what's the value of this? If I apply this to even something as simple as this, I get the same answer. So memorize one thing. If you're going to memorize anything, memorize that, because that will carry you through every problem that you have. Okay, let's go on. The same thing's going to happen down here. This is the natural log. We know it to be 1 divided by x. If you look at this problem here, it's about the same, except instead of having base e, you've got base a. So here we go. It's going to be 1 divided by a to the x. Oops, hang on a second, I made a mistake. I'm a little too enthused about those. We have 1 divided by, notice that it's x here, it's base e, log of x base e. Here's the log of x base a, so this is 1 divided by x, times the natural log, whoops, I'm sorry, I'm just forgetting all my steps here, times 1 divided by the natural log of a. What I was trying to get to is, how am I going to remember that when I take the derivative of a log, I have 1 divided by the quantity, the expression, times the reciprocal, 1 divided by the natural log of a. Up here, I don't have the reciprocal. How will I be able to keep those straight? Well, here's one thought. If you know this, it's 1 divided by x. This has to be in the same idea, 1 divided by, okay? So just kind of, these have to kind of match. Up here you don't have you don't have a fraction. Down here you do. So just kind of keep that in mind. Okay, well let's look at this. This is, again, the more complicated one. You don't have a log of base e, and you don't have just a simple x up here. So what are we going to do? Well, first thing you do is take the reciprocal of the quantity. 1 divided by u times Same thing we did over here. 1 divided by the natural log of the base of that logarithm. And what's the only thing we haven't taken the derivative of? Yeah, that quantity there, which is u in this case. So this would be the derivative of u with respect to x. We're going to see an example of this one, so I won't give you one right now. But again, if I'm going to memorize any of these down here, I'm going to memorize this one because it's complicated. But even if I apply it up here, it's going to work. Let's see it. So let me write it down here. If I apply this rule, let's see, it's 1 divided by the quantity, so 1 divided by x, times 1 divided by the natural log of the base, 1 divided by the natural log. What's the base over here? E. Okay. Times the derivative of the quantity, so the derivative with respect to x of x. Again, the natural log of e is simply, we just did it, 1. Okay, so this is 1 divided by x times 1. What's the derivative of x with respect to itself? 1. Okay, so I'm back to 1 divided by x. So this is the one. If you're going to memorize anything, try to memorize this one. This one's always going to work for us. Okay, let's look at an example. Here we go. Now there's 2 ways you can look at this problem. And it really depends on what kind of strikes you first. You know, what do you see first in the problem? One way to do it is to treat it as you see it here. Now this is one of those log problems. It's not base E, so we have to use that expanded form. So we'd have to say, one method. I better start with the same thing that I did the other class. That way then, if I take theirs, you won't be confused and post it. Let me go with the second way, the other way. Method 1 would be, let's take this and let's write this log statement out in an expanded format. By that I mean, if I look at this and I think of the log of a quotient, what's that rule? The log of a quotient is the difference of the 2 logs. Okay, and then I look at the numerator, I've got the log of a product up here, and so the log of a product is the same as the sum of 2 logs. Okay, and if I look at this quantity, I've got the log of a value raised to the 1/2 power. We have the log of something to a power. How do you take the exponent times the log? So what we can do is we could rewrite this as, let me just check my notes here, it would be log base 3 of x plus 1/2 log base 3 of x minus 1 minus the log base 3 of 2. So I'm just interpreting this in a way where I'm using those log properties. The log of a quotient is the difference of the 2 logs. The log of a product is the sum of the 2 logs. The log of a quantity raised to a power is the power times the log. Now if I do this, it may be easier, it may not be, depends on what you first saw. Let's continue with this again. In case I take theirs, you won't be confused by what you see there. If I look at the derivative of this, we've got 3 derivatives to take. The log of x base 3, okay, that's not the natural log, so we have to use one of those others. Okay, so the derivative of a log, so the derivative with respect to x, I'm going to write each of these out so those of you who might be wondering where all the derivatives, in fact, I'm going to put the 1/2 outside. Remember, if you have a scalar multiplier, you can move it outside. Oops. Let's put the derivative there. Now what's the derivative of this last log going to be? Yeah, once again, Allie? Yeah, why? It's just a constant. Yeah, just a constant. So derivative of a constant is going to be 0. Okay, so we've got, this is the log, the derivative of a log. Remember, we start with 1 divided by the expression, so 1 divided by x. It's not the natural log, so we have to say times 1 divided by the natural log of the base, so 1 divided by the natural log of 3. Make that a little better for you. And then I have to take the derivative of the expression, so the derivative with respect to x of x. And then moving on, we're going to have 1/2 plus the 1/2. Now, the derivative of the log of x minus 1 is going to be 1 divided by that whole quantity, x minus 1. Whatever that quantity is, we take its reciprocal, times 1 divided by the natural log of the base. What's the base here? It's 3, so 1 divided by natural log of 3, times the derivative with respect to x of the expression x minus 1. And we already know the last one is 0. So we have 1 divided by x. I'm going to actually multiply times the natural log of 3, this whole piece. Derivative of x with respect to itself? Just 1, yeah. Plus 1/2. Now if I look at this, I could actually say plus 1 divided by 2, the quantity x minus 1, natural log of 3. That's combining the 3 fractions here. What's the derivative of x minus 1? 1 again. So my derivative is just these 2 fractions. Now, if we could leave it like that. However, I will tell you that if you check this on the Inspire, you're not going to get 1 divided by x natural log 3 plus 1 divided by 2 quantity x minus 1 natural log 3. You're going to get something like this. So let me just give you what that is, and it's 3x minus 2. And what they've done is just to write it as 1 fraction, not as 2. So then we have 2x, the quantity x minus 1, natural log 3. You're going to find your answers to be needing to be checked, because I can almost guarantee you that a lot of these are not going to check out exactly what the Inspire says, so you have to know. You take your answer and you set it equal to what the Inspire answer or the back of the book answer says, and if they're equivalent, it's okay with me. Now, let's go back and look at some of the work you need. You need to show me the derivatives you plan to take, and that would be 2 lines of showing me the derivatives you plan to take, and then actually take the derivatives. I would like to see 2 lines of algebra, and so we kind of skip those in here. Now, that's method 1. Method 2 is, yep, I see that. Thank you. I'm going to, before that quits, I'm going to hopefully copy that, and we're going to look at method 2. Okay.